Hey guys, this is Notes 43. So today we're graphing exponential equations. So we are looking to see what an exponential graph looks like. So an exponential function is a function with the base as a number and a variable in the exponent. So we're used to seeing things like x squared, and today we're going to turn into 2 to the power of x. Something like that. This would be an exponential function. And then the other word that we're going to need to know is the word asymptote, a line that the function approaches but never touches. Right? So it gets really close but never touches it. So today we're going to be using your graphing calculator. So if you could, you're going to follow these steps. And your first thing that you're going to do is you're just going to go through and look at all 5 of these graphs and just go ahead and pull up a table. So when you pull up the table, you're going to go to the y equals screen. You're going to enter the equation in y1. You're going to press second and then table, which is the graph button. And then you're going to scroll up and down and use those points in order to make an XY table on your graph. So you can go ahead and pause your video right now and do that. I'm going to graph it on Desmos because that's what I have on my screen here. So let's see, Desmos. All right, so you can do this on Desmos too if you want. I'm going to try and dual screen my screen here. All right. All right, so what we have here is 3 times 2 to the power of x, something that looks like this. So this is our new function here. You're going to follow your calculator steps in order to find your x and y table. I'm going to do that on Desmos by clicking this button and making it a table. So I can see my points there are -2, 0.75, -1, 1.5, 0, 3, 1, 6, and 2, 12. So now I'm going to say, all right, I've got -2, 0.75 right about there, -1, 1.5 right about here, 0, 3 right about there, 1, 6 here, and 2, 12 is off my graph. So I can see that this line goes here. What I can see is that this is getting closer and closer to 0 without ever touching it, right? No matter how far I scan over here, I'm never going to get to 0. And so what that's called is an asymptote. I'd say that there's an asymptote right here. Not something that we need to know right now, but an asymptote is something that the line never touches. So I can graph my second one here. I can say, okay, instead of graphing 3 times 2 to the x, I'm going to graph -3 times 2 to the x and see what happens. So I'm going to go here, put a -3 in front. I see that my graph flipped over. So I'm going to look at those points again. I see -2, -0.75, -1, -0.75. These ones here, 0, -3, 6, and 12. And I see that the line goes just like this graph. And then right here, you're going to write in something you notice that's different. So for this example, I might I noticed that this is different because it is flipped over the x-axis. Right, so I'm going to go ahead and say that. It's your job to do these 3. So you're doing 1, 2, and 3 on your own calculators, graph them, and then write what you noticed. We'll be back in just a second. All right. Once we've graphed them and we've looked at what you noticed, we're going to talk about what the transformations are. So if I'm looking at my transformations here, there's a standard form. We've seen the standard form before. This is like y equals mx plus b, or x squared plus b squared, or bx plus c. any of the standard forms. So we see our standard form here. This is for exponential functions. And when we deal with our exponential functions, we have a, b, h, and k. We recognize h and k. H moves left and right, just like normal. It's always going to move left and right in the opposite direction, remember, because it's like in parentheses. And then k is always going to move up and down. We've seen this over and over and over again. We'll continue to see that for all of math. The big differences here are a and b. So if a is negative, we saw that the graph is reflected over the x-axis. And then what you may have seen, what you may not have seen, is that when b turns into a fraction, so when this inside piece turns into a fraction, the graph is reflected over the y-axis, right? So instead of seeing a graph that looks like this, we would then see a graph that looks like that. So if we want to move our graph over the x-axis, we would see something that's like this turn into something like that. So pretty simple. That's how we move it to all four coordinates. So if I'm looking at number 1 here, I see that the x doesn't have anything next to it, so the horizontal translation is nothing. And then I see that the 1 is my k. That means that k units up if k is positive, so I'm going to move up 1 unit. So what that means is that that asymptote that we were talking about is now at 1. Let me see if I can draw a better line here. It's going to never touch this line instead of that x-axis. So when I go to draw my line, I'm just going to go ahead and draw it like this. Right? And this was a normal orientation because there's no fraction here and there's no negative number in front there. So let's take a look at another one that might be a little different. So horizontal translation, we look next to the x. Right here it says -2. I remember that this is like in parentheses. So that's going to mean my negative numbers go to the left. So this is going to go to the right. This is a right 2 because it's the opposite. Right. My vertical translation is none. There's nothing here, no k. So I'm not going to have any vertical translation. So I know that my asymptote is going to be on the x-axis. And then my orientation. Let's see. So the a here, this is the a part here because the 5 is the b. So a is -1/2. So up here it says that if a is negative, the graph is reflected over the x. So I'm going to write reflected over x, which basically means that it's upside down. All right, so that first point, my first point is it's to the right too. So I'm moving in this direction too. And so I might put my first point like right here and then graph out like that. So I can see that it's upside down and it's to the right too. I can go ahead and check this with my, Desmos, which is here. So let's see. Right. Come on, somebody. You can do it. Check this with Desmos. So I'll clear that out and I'll put in y equals -1/2 5 times 5 to the power of x minus. Notice how the minus jumped down there. I don't want my minus to be there. I want my minus to be here. So it looks like Desmos needs me to put it in parentheses. So I'm going to jump up here, put x minus 2. And I can see that my graph is, as I said, it's shifted over just a little bit and it's upside down. So go ahead and try these ones. You're just writing down their horizontal translation, so looking at this part, and then writing down their vertical translation, looking at this part, and then writing down their orientation. So that's looking at these two numbers. Remember that the first number is going to tell you if it is upside down or right side up, and then the B number, so A is going to tell you upside down or right side up, and the B number is going to tell you like if it opens to the left side like normal, or if it opens to the right side. So you can check that out, and then always check on your calculator. After you're finished, you're going to be working on assignment 43. Thanks, guys.